Hi, I'm Ramesh. The present video focuses on screencast of my own classroom on nanomaterials for UG first year students under physics. So far I didn't use screencast video for classroom lecture. This is my first screencast lecture. This screencast video targeted uh, UG first year students under the subject title Nanomaterials Size Effects. Next, we'll see learning objectives, identifying the differences between bulk and nano size, explain the size effects using surface area to volume ratio. Now, learning objectives, identifying the difference between bulk and nano size. Under recall option, list names of bulk and nano size in daily observable objects. Give a label map for nano size in nature. Comparison between meter, centimeter, millimeter, and nanometer. Understand. Nano means size of the object of the order 10 to the power of minus 9 meters. In nature, many objects like living organisms, materials, etc. size is not same. With respect to size, one can classify bulk and nanomaterials. Next, we'll see this to get more clarity on difference between nano and bulk materials. If you carefully observe the scale, a centimeter and here nanometer. So in centimeter, many things are observable. Uh, a human eye can observe this at centimeter, and you see things in natural ant, dust mite, fly ash, and red blood cells with white cells, and DNA atoms at atomic level. And you see carefully, human hair thickness is in micrometer range. So whereas atoms are at nanometers level, and if you see things man-made, head of the pin in centimeter range, and MEMS micro electromechanical devices, and NEMS also comes under nano range. And if you see carbon nanotube, using carbon nanotubes, nanotube electrodes and nanotube transistors can be studied. So this main observable things in a scale, that is bulk scale to nanoscale. So again, next we'll move to 15. Next, second learning objective, explain the size effects using surface area to volume ratio. The recall, surface area of sphere, volume of sphere, surface area to volume ratio. Understand. Radius of sphere, surface area and volume. Based on surface area and volume ratio, there is a change in physical, chemical and electrolyte properties of materials. To get more clarity, we'll go to another slide. See here, nanomaterials have a relatively greater surface area when compared to the same volume or mass of the same material in the bulk form. For example, consider a cube of 1 meter cube volume. It has surface area of 6 meters square. Just carefully check this one, 1 meter cube and area, so 6 into 1 meter square. And then if the cube is of same volume is divided into 8 small cubes, then total surface area increases to 12 meters square. And carefully you see, previously 1 meter cube, 1 meter of cube, now the same 1 meter is sliced into 8 cubes, then the area will be, so then we'll go to third example. Further, dividing cube leads to increase in surface area. This is illustrated in the following figures. Also, if the size of the nanomaterial decreases, a greater proportion of atoms are formed at the surface compared to those inside. This makes materials more chemically reactive. And if the same cube, if you compare the same cube sliced into 9 pieces, then area will be of 18 meter square. So now if we see large surface to volume ratio, nanomaterials have a relatively large surface area to volume ratio when compared to the same volume of the material in bulk form. For example, consider a sphere of radius r. Its surface area is 4 pi r square and volume is 4 pi r cube by 3. Then if you take surface area to volume ratio, and it will leads to 3 by r. Here ratio surface area to volume ratio is inversely proportional to r, that is, as r decreases, surface area to volume ratio increases. So this is size of the particle. So size of the particle, radius depends on the surface area to volume ratio. Again we'll move back to PPT. And so bulk size, nano size, surface area, volume, comparison between bulk and nano size, importance. It's the end of slide. Thank you.